Module 8, problem number 3. A manufacturer of colored candy states that 13% of the candies in a bag should be brown, 14% yellow, 13% red, 24% blue, and 20% orange, and 16% green. A student randomly selected a bag of colored candies. He counted the number of candies of each color and obtained the results shown in the table. Test whether the bag of colored candies follows the distribution stated above at the alpha equals 0.05 level of significance. So what we have is we are going to have a bag of candies. Let's say that they're M&Ms. And we're going to count out how many of those colors that we have. We have yellow, red, blue, orange, and green. And so, and brown, excuse me. And so we're going to count up, that's going to be our observed column or our observed data. Now, we do need to find out what we expected because we're given these percentages or proportions if we divide them by 100. And we need to take that to figure out what's our expected counts. So first, let's go ahead and dive into the first part. He says here, determine the null and alternative hypotheses. Choose the correct answer below. Remember, our null hypothesis is that is always that the distribution is the same as like the observed and expected. So in this case, we would say that the null hypothesis is the distribution of colors is the same as stated by the manufacturer. That means that our alternative is that they are not the same. So let's go ahead and click, that's option B there, final check. Fantastic. Continue. All right, so now we're given this table and we need to come up with our column of expected counts, like I was just saying. So what I went ahead and did in Excel, I just copied this just for the ease of use. So I took this table here, and you see here we have brown, yellow, red, blue, orange, and green, and we have the frequency, the claimed proportion, and the expected counts. So the way to do this, and this is just in Excel, you can do this in a calculator. You don't have to do it like this. I just thought this would be the easiest way to show you guys. You're going to total up this frequency column. So you want to know how many M&Ms or colored candies you have. So we're going to click OK. So that gives us 403. So when all I did was add up all of these different colors that we found in the bag, and this is the total, is 403 candies. Now, our expected count is going to be that 403 times this claimed proportions. The idea is if we didn't have this bag of candies, if we were just told, here's 403 candies, what would you expect? We would expect based on what the manufacturer told us. So to find those expected counts, we're going to say, we're going to multiply this proportion by that total there for all of these. Oops, so that equals this times 403. And we're just going to drag that down for all of those. And that gives us our new expected counts. So now I'm going to go through and type those in here. So we have for brown, and I have them in the same order, for 52.39, because it says here to round to 2 decimal places, which all of these are at 2 decimal places. Yellow, we have 56.42. Red, we have 52.39, which we'd expect to be the same as brown because the claim proportion was the same. And then blue, we have 96.72. For orange, we have 80.6. And for green, we have 64.48. Check answer. Well done. All right, that's how we find our expected counts column. Now, what do we need to do with this? We need to come up with our test statistic. So we could do this in Excel, but I am going to do this in StatCrunch because it is a little easier, and I think for your guys' purposes, we've been working in StatCrunch this whole time. So I'm going to create the observed column and the expected column, and I'm just going to copy in those numbers, 63, 64, 56, 59, 98, 63. Expected, we have 52.39, 56.42, 52.39, 96.72, 80.6, and 64.48. This is quite riveting video, I'm sure. All right, now that we have our 2 columns, we need to go to Stat. We need to go down to Goodness of Fit test, and we're doing the chi-square. Our observed column is OBS for observed, and our expected is EXP. Click Compute, and there we have our chi-square, our test statistic, and our p-value. So let's go ahead and put in our test statistic, and it says round to 3. So we had 21.917. Check answer. Excellent. All right, and the p-value, again, round to 3 decimal places. That would be 0.001 because that rounds up. 001. Check answer. Well done. All right. Based on the results, do the colors follow the same distribution as stated in the problem? Well, we know from our multiple hypothesis test that when the p-value is less than alpha, we reject the null hypothesis. So we already know we're looking at options A or D. When we reject the null hypothesis, we're saying that there is sufficient evidence to support our alternative. Remember, our alternative is that they are not the same. Those proportions that are expected and observed were not the same. So that would say there is sufficient evidence that the distribution of colors is not the same as stated by the manufacturer. That's option A. Check answer. Fantastic. So that's how you do problem number 3. I hope this clarifies for anyone having a hard time with the chi-square test. If you have any questions, let me know.